When we're talking about optical transceivers, we generally look at the optical power budget to determine the distance that is achievable. However, did you know that there is an additional value that is just as important to make sure that this distance is achievable? If you want to find out more, stick around and we'll check it out. Now, the optical power budget basically is the delta between the optical output power of the transmitter and the sensitivity of the receiver. Now, the point is that between the transmit and the receive, we have various different elements that take away the optical power. So in other words, we're talking about connectors, splices, and of course also the attenuation per kilometer of the fiber cable. Now, the important thing obviously is that the sum of all these elements that take up the optical power needs to be less than the optical power budget. However, the optical power doesn't actually say anything about the amplitude of the signal, but that is very important for the receiver to be able to decode the signal. Let me explain. Now, the majority of the transceivers that we use nowadays for distances up to 80 or 100 kilometers actually use a so-called non-return to zero optical modulation, or short NRZ. Now, what that means is that the optical signal actually has two states. It's got a higher and a lower state. If we have a look here at this measurement of an NRZ signal, you will actually see those two states. So we have the higher state, which is at 2 milliwatts, and we've got the lower state, which is at roughly 0.6 milliwatt. Now, the important thing to note is this so-called DC component. And that DC component we always have for various different technical reasons. However, this DC component can vary in height. So now let's have a look at how we actually measure an optical power. And what the optical power actually is, it's a measurement of the average. So it measures actually the average between the higher and the lower state. But what that actually means is that the optical power doesn't say anything about the optical amplitude. But of course, the optical amplitude is very important for the receiver to be able to decode the signal. So what we then do is actually look at the so-called OMA, which is the optical modulation amplitude. And that is the actual delta between the higher and the lower state. However, to make things easier, and also if you look into a data sheet of a transceiver, you will rarely find the OMA, but instead you will find the so-called extinction ratio. And the extinction ratio is actually the ratio between the higher and the lower state. Now, if we have a look then again at two examples, you will see here two signals that have the exact same optical power, so they both have 1.1 dBm, but the extinction ratios are different. On the left side, we've got an extinction ratio of 14, and on the right-hand side, we have an extinction ratio of 4. Now, as stated before, all the elements between the transmit and the receive in a link actually draw away optical power, meaning they reduce the amplitude of the signal. So that's why this signal here with the extinction ratio of 14 will have a much further reach than the signal with an extinction ratio of 4. Now, the point is you don't actually now need to worry and always check for the extinction ratio when you're trying to find a new transceiver, because the standards actually always define an extinction ratio for the different types of transceivers to be able to easily reach the distance. However, if you are looking for a transceiver or trying to use a transceiver just beyond that specified distance, the extinction ratio can give you a good indication if it actually is possible. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment and see you next time.